Children, next wave terminology. Sound, it is a wave. Wave is nothing but the disturbance created in the medium. So that in order to understand the sound waves, we need certain terminology or certain parameters in order to understand the properties of the waves. Here first one is amplitude. When a wave passes through a medium, the maximum displacement of the particle of a medium on either side of its mean position is called the amplitude of the wave. It is denoted by the symbol small a. The SI it is in terms of SI system meter. Amplitude is nothing but the whenever the wave is traveling from the one point to another point, the particle is vibrating perpendicularly either parallelly. The maximum displacement, we call it as the amplitude of the wave. We will understand with the help of the graphical method. It is denoted by the symbol A, SI it is meter. That is the amplitude. Next, time period. Time period is nothing but the time taken by a particle of medium to complete its one vibration. Whenever the particle is completed one vibration, then how much time it is taken? That is called as the time period of the wave. Let us take an example, hour hand, minute hand and second hand in the watch. Whenever in order to complete the one rotation or revolution, rotation of the corresponding hour hand, next again the minute hand and again the second hand, 60 seconds of the time period of the second hand, because of it after 60 seconds it come back to the same location. Similarly, minute hand also 60 minutes. Next, generally our hand after 12 hours it come back to the same location. So that the time period of the hour hand is 12 hours. The time period of the minute hand is 60 minutes. The time period of the second hand is 60 seconds. That is the time period. Time period is nothing but here the wave is traveling from one point to another point in the form of the particles. The particle completed one vibration. Then how much time it takes? That is called as a time period of the corresponding wave. It is denoted by the capital T letter, SI it is seconds. Next, frequency. The number of vibration made by the particle of medium in 1 second is called the frequency of the wave. It is denoted by the generally small f, small n, or it is a Greek symbol nu, pronunciation as N-E-U, nu. SI it is hertz. That is the frequency. Frequency is nothing but the number of oscillation per second. Per second, how many oscillation it is making, that is called as the frequency of the corresponding wave. If you take a drum, vibrate it, wait 1 second. After that, how many vibration it is making in second, 1 second is called as the frequency of the corresponding drum. Next, the relation between the frequency and time period both are related as the reciprocal of the time period is called as the frequency, or the reciprocal of the frequency is called as the time period. F is equals to 1 by t is the relation between the f and t, frequency and time period, or t is equals to 1 divided by f. Next, wavelength. Wavelength is nothing but the distance traveled by the wave in one time period. Wait one time period or one vibration, how much distance it is traveled. That is called as the wavelength of the corresponding wave. It is denoted by the symbol, letter Greek symbol lambda, L-A-M-B-D-A pronunciation, and SI unit of corresponding is it is a meter. Generally, in the case of the sound waves, it is longitudinal waves, compressions and rarefractions are produced. The distance between the one compression and from the one compression to the one rarefaction is called as a wavelength of the wave. But in the case of the transverse waves, crusts and troughs are produced. The distance between the one complete crust and one complete trough, the distance between those two is called as the wavelength of the corresponding wave. Next, last one is the wave velocity. Wave velocity is nothing but how fast an wave is moving. What is the meaning of velocity? How fast an object is moving. Here the wave is moving. Means sound is moving from the production to the listener. That is the distance traveled by the wave in 1 second. In 1 second, how much fast or how much distance it is traveling, that is the wave velocity. It is denoted by the symbol V. Then SI unit of that one is meter per second. Already you know the velocity will be measured in terms of meter per second, denoted by the meter second power of -1 meter per second. That is the wave velocity. These are all the certain terminologies which are related to the wave characteristics. Next graphs, displacement time graph. Here the graph along the x-axis is time, along the y-axis is displacement. This is the behavior of the wave. In the case of the either longitudinal wave or transverse wave. But in order to understand the amplitude and everything, we should take a transverse waves. Here the transverse wave, this is a displacement. It is a mean position. It is a displacement. Suppose if we take a rope fixed one end and again if you vibrate up and down oscillation, it makes like this one. It is an amplitude at each and every point on the wave from the mean position. Here also the same thing. The maximum displacement means from here to peak point. Here to here also. It is the amplitude of the wave. And again here also. And again here also. The maximum displacement on either side of the wave. This is the one side, this is the other side. This is called as the amplitude of the wave. Next time period is nothing but the one vibration completed. One vibration completed means from here to this is a half vibration and again here also a half vibration. One completed. From here to here the wave is completed. Again it is repeated. Continuously it is repeating so that how much time taken from here to here. It is a time period. From here to here also the time period only because here the some off portion is reduced here. That is covered here, so that it is a time period. Even from here to then again here also the time period. Wherever the complete vibration, how much time it is taken by the particle, whenever it is moving, it is called as a time period of the wave. That is the information getting from the displacement and time graph and a displacement distance graph. From this, so we can get the wavelength of the corresponding wave. Here wavelength is nothing but how much distance traveled to complete one vibration. Here also the same thing. Here the wave is started and again it is completion and again compared to the here one wave is completed. Again this entire portion is repeated. Even if you take the from here to here also one wavelength or here to here wavelength or here to here also one wavelength. That is the information we are getting from the displacement and distance graph. Next to relation between the here the V is nothing but the wave velocity, lambda is nothing but the wavelength and the frequency. The relation between the wave velocity, wavelength and frequency, very very important. Let velocity of the wave will be capital V. Time period is capital T, frequency F and wavelength lambda. In order to calculate the wave velocity, because of the here the wave velocity is nothing but in the specified direction. Suppose we take a distance, in order to calculate the distance with the help of the formula, distance equals to the time into speed. Here the speed is a scalar quantity, so the distance is equals to time into speed. I want the speed here. What I should do? Distance divided by time. Same here also. Here the speed is nothing but it is having certain direction, so that it is a velocity. What it is moving is a wave, so that wave velocity equals to the distance traveled by the wave divided by time taken by the wave. Based on this formula, distance traveled by the wave divided by time taken by the wave. Then capital V equals to the distance traveled by the wave. One complete vibration, how much distance lambda wavelength divided by time taken to complete one vibration is time period T. Then V is equals to lambda 1 by T. Again, the relation between the frequency and time period, the reciprocal of the time period is a frequency. So that lambda into F, V equals to the F into lambda. Therefore, the wave velocity is equals to the product of frequency and wavelength. The relation between the wave velocity, frequency and wavelength is wave velocity is equals to the product of frequency and wavelength. That is the relation between those three.